All right, this is the Chapter 2 free response question posted to Canvas. I'm going to take a few minutes to go through each of the components to it. Let's start with Part A. The distribution of scores on a recent test closely followed a normal distribution with a mean of 22 and a standard deviation of 4 points. So, excuse my scribbling, there's a standard deviation formula, mean notation and mean notation. Question A says, what proportion of students scored at least 25 points on this test? There are really two approaches to this problem, but all of them are going to require a diagram. I always want to draw a diagram. You don't have to list 3 standard deviations out, but at least have where the mean is and maybe a couple so the point is across. And you want to have a definite boundary here. So this is at least 25 points. That means I'm going to mark there at 25 and shade to the right. So a diagram and notation is always good. You can just say normal 22, 4, or you can list that out. But then you want to talk about, if you're doing it using method 1, you'd have to get a z-score. So the z-score is always the value minus the mean divided by the standard deviation. So in this case, 25 minus 22 is 3, divided by the standard deviation is 3/4, 0.75. Then you would need to look in the table, table A, and you can look at 0.7 and then go over to 0, 1, 2, 3, 4, 5, and you can see that that percent is 0.7734, and that's the percent below, because remember table A is always below a certain z-score. So to get the percent above it, you would have to subtract that from 100% or 1. So 1 minus that is going to be 0.2266. The other method is the method I typically use, and I use Normalcdf in the calculator. So I'll do second bars, Normalcdf. And you gotta know what to input. So since it's being shaded above, you wanna make your lower value that cutoff point, so 25. Your upper has to be infinity, because this is gonna go on forever. So you would say 1 E99. Your mean would be 22, and your standard deviation would be 4. And your calculator does allow you to, since this has an upper bound of infinity, it's going to give you the correct percentage, 0.2266. So a diagram and work to get your percentage is required. But then you want to write it up. So in conclusion, the most important part is to summarize. That's where you're going to get half your points from. From the distribution of test scores, about 22.66% of students scored at least 25 points. So keep that in mind as you're doing that problem. Number 2, or letter B. What is the 31st percentile of test scores? Remember, percentiles at or below a certain value. So we want to know in a diagram about what value here is going to give us 31%. Okay, that's something to think about. We got 2 methods to use here. One method would be going back into the table and using table A. We would have to find on table A approximately where is 31%. So this isn't where the z-score is negative because it's left of the mean. 31%. You see a 30.3121, but you also see a 0.3085, and 0.3085 is actually closer. So that z-score looking out would be negative 0.50, so negative 0.5. From there, you have to solve for the x value. So given your z-score, you do x minus your mean, which is 22 over 4, multiplied by 4, negative 2, and then add the 22 to your -2 to get 20. So that x value should be 20 right there. So 20 is at the 31st percentile. The other approach for that is inverse norm. You do second vars. You go down to the third option. The area would be 0.31, mean of 22. If you have an older calculator, put a comma between your numbers. And that also gives you 20. So to interpret it, for this distribution, a test score of 20 would be at the 31st percentile. So you could also say about 31% of students scored at or below 20. Part C. Part C is probably the hardest one. Let me explain what's going on here. The teacher wants to transform the test score so that they will have approximately normal distribution with a mean of 80 points and a standard deviation of 10. Because you know in the gradebook you want to have your stuff go to 100, right? So the mean's going to be converted to 80, standard deviation is 10. To do this, she will use a formula in the form new score equals A plus B times the old score. We want to find the values of A and B. There is no table or calculator method here. We have a specific way we got to do this problem. So reminder that the old mean was 22 and the old standard deviation was 4. And we want to get it to be 80 and 10 respectively. So whether you're using this formula for the mean, remember that adding, subtracting, multiplying, and dividing can change locations and centers. So mean would be changed by doing both adding and multiplying. With the standard deviation, the only thing that affects spread is multiplying and dividing. So this B times the old standard deviation would work, but not the A. Well, that's the only reason we can actually solve this, because we don't need to know what A is for this one. That means my new standard deviation should be B times the old. Remember the old was 4. Well, I know my new standard deviation is desirable at 10. That's where the teacher wants it to be. So if I know that that's where it should be, and I know my old standard deviation is 4, and I don't have to worry about A because adding and subtracting doesn't change the spread, doesn't change how far apart the values are, then I can simply divide by 4 to get a value B of 2.5. Now that I have that, I'm gonna go over here, and to get my new mean, we want our new mean to be 80. We have an old mean of 22. I had a big old mistake on there and I just had to fix that. So let's try that again. We have that value of B is 2.5. We have a new mean we want to be 80 from the problem up here. The old mean was 22, not 4. I had 4 written. Well, I have my B value, that's 2.5. So since B is 2.5, we can actually go ahead and put that in. Just plug that in over here. Multiply those and you're going to get 55. And then to solve for A, you could subtract. So 80 minus 55 is going to be 25. So this one is just crunching some numbers, but your new formula, your A value should be 25 and your B value should be 2.5. 25 plus 2.5 times the old score will give you the new score. Letter D. Before the test, the teacher gave a review assignment for homework. The maximum score on the assignment was 10 points. The distribution of scores on this assignment had a mean of 9.2 points and a standard deviation of 2.1 points. Would it be appropriate to use a normal distribution to calculate the proportion of students who scored below 7 points on this assignment? Explain your answer. So to understand this, if I were to draw a normal curve out with a mean of 9.2 and a standard deviation of 2.1, you should, if this were normally distributed, you should have the majority of your data be between 8.1 and 11.3. Well, that's 68% of your data. 95% of your data should be between 7 and 13.4, and almost all, 99.7% of your data should be between 5.9 and 15.5. Well, it's a problem because you can only score 10 points here. So your max is going to be at 10. So there really isn't any of this going on, right? So this data is not normal. In fact, this data would be probably skewed to the left because you have this mean of 9.2 and your standard deviation is pretty high compared to these numbers, right? You only have a number between 0 and 10. So you want to say something like it would not be appropriate to use a normal distribution to calculate the proportion of students who scored below 7, since the maximum value is less than 1 standard deviation above the mean. That's kind of my biggest thing here. The maximum value at 10, that's not even, that's like half a standard deviation above the mean, but if it were normal, you'd want to have more values up there. So the distribution would not be normal, it's possibly skewed to the left. So that's why. Thank you for watching. Hopefully you have a good day.